Good morning, ladies and gentlemen. Thank you for joining me today. Let me introduce myself. My name is Nawaratnamta from Institute of Public Health, Suranari University of Technology, and I am so honored to be here today. So I would like to present about the topic assessment of health risk associated with particulate matter exposure from traffic in the informal worker of Nakhon Ratchasima. There are three key points I will be discussing. First one is the PM caused by traffic in urban area, especially PM10 and PM2.5. The second is health risk assessment in informal worker nearby traffic areas. And the third is about traffic-induced PM risk control management for the informal workers. These are the outline for the today presentation. Okay. Let me start with the introduction. As you can see that World Health Organization or the WHO have reported about 90% of the global populations reside in area with air pollutant level passing recommend guidelines. So the emission from pollutant from the road traffic is strongly correlated with the concentration of particle in urban area or congestion areas. So exposure to particulate matter that released from vehicle can cause the health effect, especially PM10 and PM2.5. So talk about the majority sources of the PM from caused by traffic. They come from many sources such as transportation, industrial growth, household activity, and agriculture. But we found that around 50% of air pollution, such as PM10 and PM2.5, that originate primarily from traffic in urban areas. Okay, in 2019, the annual average concentration of PM2.5 in the urban area of European Union or EU have the annual average concentration higher than the WHO recommended. Also in Thailand, as you can see in the graph, this is the annual concentration of PM10 and PM2.5 in Thailand in 2023. You can see that all are exceeding the annual standard, both of PM10 and PM2.5 since the 2017 to 2023. So let's talk about the health effect of PM10 and PM2.5. They can affect to the human body, such as the respiratory system, the cardiovascular system, nervous system, and it's also the carcinogen group in the first group. Okay, next is the Nakhon Ratchasima province. Nakhon Ratchasima is a large province with the second largest population in Thailand. It has a developed industrial and construction sector and a dense population in urban areas. This has resulted in the province having the highest number of vehicles in the northeast region. This has led to congestion and traffic jam and the average annual concentration of PM10 and PM2.5, and you can see in the graph, especially in the PM2.5, it has exceeded the standard for 4 years consecutive. From the data that I mentioned above, you can see that people who live or work nearby the traffic areas, such as street vendor, motorcycle or delivery driver, or security guard, etc., have a opportunity to be exposed to these particles and have health impact. Okay, this is a matter and method. This research is a cross-sectional descriptive study. We have a PM10 and PM2.5 concentration measurement, which are the secondary data from Pollution Control Department, and we also have primary sources data from PAS instrument. We collect the exposure information by using the questionnaire. So the questionnaire was developed from OSH Respirator Medical Evaluation Questionnaires. And the last one is health risk assessment. We use the method from the U.S. Environmental Agency or US EPA. Okay, in addition to the PM10 and PM2.5 concentration, which are the secondary data from Pollution Control Department, the researcher measure and collect particle sample to confirm the data by using the following instrument. The first one is particle size distribution and particle concentration measurement. We using the PAS model GRIM 11D. And for the particle sampling, we use IOM sample with a polycarbonate filter. And for the particle sample analysis, we use the FESCM EDS instrument. Okay, next is the sample group. We collect the sample group by the purposive selection of 100 people with the inclusion and exclusion criterion as follow, and you can see in the slide. So this is the picture of heavy traffic in urban area of Nakhon Ratchasima province, and the data collection of the sample group and the setting up instrument to measure and collect sample from the particle that generated from traffic. Next is the health risk assessment. We use the method from the US EPA, which are the 4 steps that you can see on the slide. The first step is hazard identification. The first step is a process of the determining whether exposure to hazard that can cause to health effect. So for this research, is the hazard is the PM10 and PM2.5 that caused by traffic. Next step is the dose response assessment. This step is involved describing the quantitative relationship between the amounts of exposure to PM and the extent to the effect. The third step is exposure assessment. This step is a process of measuring or estimating the magnitude, frequency, and duration of exposure calculated by ADD or average daily dose for the non-carcinogenic effect as the equation and the value in the table on the slides. The fourth step is the risk characterization. This step is a process of identifying risk value by using the result from the previous step that I mentioned to calculate the risk or chance of an impact from exposure to PM10 and PM2.5 by calculating from hazard quotient or HQ. If HQ more than 1, that meaning expected to cause health risk from PM10 and PM2.5 exposure. Okay, we next to the result. The first result is the demographic data of the sample group. The first one, we found that the occupation of the sample group found that most were students at 43%, followed by the informal workers such as motorcycle delivery driver, street vendor, and security at 30%. And we found that most of the sample group were female at 55%. The age and weight data will show as a table, and you can see on the slide. Okay, this is the secondary data, the result of PM10 and PM2.5 concentration measurement from Pollution Control Department in Nakhon Ratchasima province in 2023. You can see that the value were high in the first half of the year and it decreasing in the second half of the year. The highest concentration value were found in March. In addition, the obtained 95th percentile value will be used to the exposure assessment and the risk calculation step for the health risk assessment. Okay, next will be the result from the particle measurement and sampling that the researcher have conducted to confirm the data. The first will be the particle size, distribution, and number concentration from PAS instrument, which found that the particles had the highest size at the 0.253 micrometers and began to decrease at the 2.982 micrometers. Next is the mass concentration from the same instrument, which is divided into occupational parameters and environmental parameters. It was found that PM10 and inhalable dust were highest concentration value, and you see in the graph. Next are the results of particle sample analysis with using FE-SEM EDS instrument. Starting with the elemental composition, it was found that the majority of sample were carbon. You can see the highest, which is an element produced by engine combustion. In addition, we found the heavy metals such as iron, aluminum, copper, zinc, titanium, and chromium. Okay, this is the morphology of particle that caused by traffic. You can see that at the low magnification, the particle size is in the micrometer level. But when we look up at the high magnification, we can see that the particle size is in nanometer level. When we looking at the shape of the particle, they are ellipsoidal, irregular, fluffy pseudo-aggregate, and spherical shape. For the result of the Harris assessment, it was found that the hazard quotient or HQ value of both PM10 and PM2.5 had a 95th percentile that exceeded the criterion standard, which are 1. Meaning that the sample group was at risk of health from exposure to both of PM10 and PM2.5. But when we looking at the for the hazard quotient of informal workers, both of the PM10 and PM2.5, it was found that both of the PM10 and PM2.5 had a hazard quotient above than 1. Which we found the motorcycle delivery had the highest hazard quotient in this group. Okay, next to the discussion. For the first one, we discussed about the Harris assessment result. From the Harris assessment result, you can see that PM10 sample group had a hazard quotient greater than 1 at around 8%, and for PM2.5 at 18%. When we considering the characteristic of work that require they have to exposure to PM10 and PM2.5, it was found that the sample group had a working hour more than 10 hours a day. They're working more than 5 days per week, and they're working in that occupation for many years. These are the reasons why this sample group have the hazard quotient more than 1. And the top 3 of sample group had the highest hazard quotient is motorcycle or delivery driver with the first rank. Next is the security guard and street vendor. Okay, let's talk about the health effect of exposure to traffic-generated particles. When we considering the measurement result from the instrument, that PAS instrument, that the researchers have studied, it was found that particles are both in micrometer and nanometer in the size. So different size of the particle can enter the body by the respiratory system at a different levels. From the result from the PS instrument, we found the peak of the particle at the size 0.253 micrometer, which is in the range of 10 to 1,000 nanometer. That means that some of the particles can accumulate in the alveoli and can be eliminated, while some can translocate to brain, heart, and immune system. Okay. We have the elemental composition results from the FE-SEM instrument. So let's talk about the health effect of that elemental that we found. For the respiratory system, this elemental can cause health effects such as asthma attack, pulmonary fibrosis, COPD, and we also found, you can see we found silicon that can cause the silicosis. For the cardiovascular system, such as atherosclerosis, heart failure, and stroke. For the other symptoms and diseases, such as induced diabetes, increase the risk of Parkinson's disease and Alzheimer's disease, and the important health effect that they can cause cancer. Okay, we finally into conclusion. From the result that discussion that I mentioned above, this finding highlight the need that we have to create the risk management control for the high-risk informal workers who are exposed to particulate matter, such as we have to establish policy to reduce particulate matter emitted by vehicle, advocating for policy promoting the use of green energy in vehicle, limiting exposure duration, and employing adequate respiratory protection such as N95 mask. For the technology that you can see, this device is an electrostatic precipitator, or ESP, from the National Science and Technology Development Agency. The ESP is an air purifier that for removing diesel engine particulate matter that use static electricity. They were tested with a diesel pickup truck at the maximum speed. The level of black smoke emission was 99%, but with the ESP device, the black smoke went down to 27%, which meet the new emission standard capped at 30%. And for the further study, due to the limitation of this study about the data that used in this study, the risk characteristics are described only in the way of non-carcinogenic effect. But we found the heavy metals that in the particulate matter that we use the FESCM instrument, we also found that heavy metal too, which these heavy metals are dangerous and also in the group 1 carcinogenic to humans. So the researcher recognized the importance of the health effect on those who are exposed, especially in this research, informal workers. Therefore, it is considered to assess the health risk in the form of carcinogenic effect to the heavy metal element in the traffic congest particle in the further study. This work was supported by Suranari University of Technology, Thailand Science Research and Innovation, and National Science Research and Innovation Fund. Okay, that brings me to the end of my presentation. Thank you for your attention and participation. I am open to your questions, discussion, and feedback from all of you in here. Thank you.